All right, thank you so much for joining us today. And in this video, we are going to go through 9 questions, different questions. So let's start. First, we have a function and we want to use the limit definition to find the derivative, right? But what I'm going to do is I'm going to just differentiate the function using the power rule. So we are going to have 2x minus 5. I just use the power rule to do this so that at the end of the day, I know that this is what I'm working towards, right? But when you just write this one as a solution, you are going to get everything wrong because the question is saying that using the limit definition. So let's do this here and then find out if using the limit definition, we are going to have this. If we are not getting this, then we know that something is wrong. So let's do that. Now, limit definition f prime of x is equal to limit h is approaching 0, f of x plus h minus f of x all divided by h. So this is the limit definition. So what do I need? I need f of x, but f of x is already given. So I have f of x, which is equal to x squared minus 5x plus 1. Now that I know f of x, I can use f of x to find f of x plus h. So f of x plus h is equal to, now for me to write the f of x plus h, I'll write f of x as, I'll put all the x's in parentheses. So I put all my x into parentheses so that I can see that I have x here in parentheses in parentheses. So if this is no longer x and it is x plus h, then this one will be x plus h, x plus h. So I'm going to have x plus h squared minus 5x plus h plus 1. So x plus h, x plus h, x plus h, x, x, x. Good. So this one helps me to do that. Let's simplify. X plus h, x plus h minus 5x minus 5h plus 1. So I multiply through by negative 5 here, and I'm having this one here. This one to the power 2 is the same as this times that. So now let's simplify this. This is going to give us x squared plus xh plus xh plus h squared minus 5x minus 5h plus 1. So what can we do? This times that, x times h, 8 times x, and h squared is giving us this. So let's do simplification here. We are going to have x squared plus 2xh when I add these two together, plus h squared minus 5x minus 5h plus 1. Can I do any simplification? No, because no term here is the same for us to add or subtract. So now we have f of x plus h, and we have f of x. Now, instead of putting everything here in place of this minus everything here, what I'm going to do is I'm going to just pick the top and simplify before we go there, right? So let's find for this. So now what is f of x plus h minus f of x? Now f of x plus h is the whole of this. So I'm going to have x squared 2xh plus h squared minus 5x minus 5h plus 1 minus, then what I'm going to do next is minus f of x, but f of x is not just one term, it's 1, 2, 3. So I need to put this one in parentheses. So 5x squared minus 5x plus 1. Let's do the simplification. X squared plus 2xh plus h squared minus 5x minus 5h plus 1 minus x squared plus 5x minus 1. So minus 1, positive 1, 5x minus 5x, x squared, x squared. So guess what? What is left is 2xh plus h squared minus 5h. So as soon as I get something like this, I can factor one of the h out because I have h here, h here, h here. So I'm going to have h out 2x plus h minus 5. Good. So I was able to find this, or I was able to simplify this, which is equal to what is here, right? So now let's write the function. Now we saw that f prime of x is equal to limit h is approaching 0, f of x plus h minus f of x divided by h. Now we know that f of x plus h minus f of x, which is this, is equal to this. So now we are going to have limit h is approaching 0, h 2x plus h minus 5 divided by h. And then the magic happens. This is going to cancel this. So the only hard work that we needed to do is trying to figure out this, figure out this. The rest is just cancellation. So you see that it's good for you to pick this and also pick this, so that when you are now just doing substitution, it's very easy for you to do that. So what are we going to get? This is going to be limit h is approaching 0, 2x plus h minus 5. Now that what is making the function so hard for me, which is divided by h, is gone, I can plug in the h and I'm going to have 2x plus 0 minus 5. And guess what? We are having 2x minus 5. Let's go and check if it's the same as the what we had. Good. So you can see that this is the same as this 2x minus 5, which is also the same as 2x minus 5. So this one helps us to confirm our results by doing the direct differentiation, and then when we use the limit definition, we compare to that. So that if this is not the same as this, then we go through to check if we done any mistake somewhere. For example, maybe if when you were writing this one, you made it positive, positive, and then this one now become positive. As soon as you check this, oh, this is negative, and you will find out that, okay, I think I did some mistake here. This one's supposed to be negative, and this one's supposed to be negative, and then you are done. So this is the first question. Let's look at question 2. Now find the average rate of change given this on the interval 1 and 3. So the first thing that we need is, what's the formula for finding the average rate of change? So average rate of change is equal to, since this one, the function is gen of x, we are going to have gen of b minus gen of a divided by b minus a. So b is here, b is here, a is here, a is here. Note that my first here is a and this one is b. Is that right? Good. So now let's do substitution. Let's try and figure them out, right? So it means that since I know b and I know a, this is going to be gen of 3 minus gen of 1 divided by 3 minus 1. I can decide to go and figure out gen of 3 and then gen of 1, then I'll come and do substitution. So let's do that somewhere here. What is gen of 3? Gen of 3 is equal to, let's plug that one inside this. This is going to be 10 minus 3 squared, which is 10 minus 9, and this is going to give us 1. What is gen of 1? This is 10 minus 1 squared, and this will be 10 minus 1, and this is going to give us 9. Good. So now let's do the substitution. Gen of 3 is 1 minus gen of 1 is 9 divided by 3 minus 1 is 2. So this is going to give us minus 8 divided by 2, and we are going to have a big minus 4. Good. So this is question 2, finding the average rate of change. Very simple, right? So all we just need to know is remember the formula and then just do direct substitution, and then you are there. Let's look at question 3. So question 3, let's try and pick the keywords inside. So we have marginal cost, right? And then we have quantity here, and then we have the total cost, So let me use different color to underline the total cost, right? And then we have price. We have price. So now we have identified all the components. So marginal cost is this, and then the quantity is there. So remember, cost is a linear function. So what's the linear function for finding cost? We know that cost of x should be equal to mx plus b. Don't forget, b is the fixed cost, and then m is the marginal cost, right? And then c of x here is actually the cost itself. So that's what we need to remember. And let me say the x here is the quantity. So we know all the terms. So this one will help us to find the fixed cost, right? So let's see what is given to us. Let me shift this one small and let's see what is given to us. So we are given the marginal cost, right? So marginal cost is equal to MC. That's the marginal cost is equal to 100. We are also given the total cost, right? So the total cost, that is 50 computers of this. So it means that the total cost, which is this, is equal to 8,000. And then we are given price. Price is also equal to $400. What is given again? I think that's all. And then we are given quantity, right? So quantity, which is the x, is equal to 50, right? So that is what this is the information from this. So how do we find the fixed cost? So since we know that this is the linear function, then we know the cost, which is 8,000. We know the marginal cost, which is 100. We know x, which is equal to 50. So we can use this function here to find for b, what is the fixed cost. So let me just plug in the x, because x is equal to 50. So I'm going to have c of 50 is equal to m times 50 plus b from here, right? So that's what you are going to get. X is 50, so I plug in 50. Now what is c of 50? C of 50 is 8,000. So I'm going to have 8,000, which is equal to, what is m? The m here, slope, is the marginal cost. So we have 100 times 50 plus b. So this one will help us to find b. So we are going to have 8,000, which is equal to 5,000 plus b. And guess what? B should be equal to 8,000 minus 5,000. And this should be equal to, I think I can use different pen to write that, 3,000. So the fixed cost is 3,000. Good. Now the question is, find cost of making X computers, right? So now we want to find cost. This is cost. So here is in terms of X. So we need to figure out this. So this is going to be phi of X is equal to, we know the slope, which is m, which is the marginal cost, which is 100. So 100. Yeah, we know X, but this one, the question did not mention, this one was 50 computers, but this one is X computers. So still X. Then plus, what is the B? The B is the fixed cost, which we just saw it was supposed to be 3,000. Good. So using this one to find B, and we will be able to write out the cost function. So this will be the cost function that we are having here. Good. Let's look at C. C, find the revenue function. Now remember, the revenue is in terms of X. So we are going to have R of X to be equal to X times price. But what is the price? Price is given. Price was given as $400, which is here. So I just sub it in. So I'm going to have x times 400, and this is 400x. Very simple. So this is xp, and then I have the, always remember, check what is here. It's very important. If this is in terms of p, if this one was r of p, then our final results here should be in terms of p. This is x, so that's the reason why my final results here is in terms of x. So always make sure you check that. Let's look at the last question under this question. We want to find profit function. Now, what's the formula for finding profit? Profit is equal to revenue minus cost. So what was the revenue? Revenue was 400x. So we are having 400x minus what was the cost? Cost is 100x plus 3000 from here. So this is the cost, and then this is the revenue. Simplify that, and you are going to have 400x minus 100x plus minus 3000. So our final results here should be 300x minus 3000. So this will be the profit function, and you can also see that this is in terms of x. So our final results here is in terms of what? X. So that's what you just need to remember. This is in terms of x. So our final answer here too is in terms of x. All right. Now let's look at the next question. Evaluate the following limit. So we are trying to find it. So remember, anytime we are dealing with limit, the first thing that we need to do is just plug it in. So let's do that. Limit x is approaching 3, x squared minus 4x plus 5. This is going to be 3 squared minus 4 times 3 plus 5. And this is going to be 9 minus 12 plus 5. And 5 plus 9 is 14. And we're supposed to get 2, I think. Yeah. So this one should be a big 2. So we don't have issue there. Now let's look at B. Anytime you are taking limit as x is approaching infinity, think about the horizontal asymptote. So anytime you need to think about horizontal asymptote, you try to compare the ones with the highest degree, right? So this is equal to limit x is approaching infinity, right? So I look at the polynomial function on the top and pick the one with the highest degree, which is 10x squared, divided by this one, the one with the highest degree, which is 3 that. So the rest of the term just goes away. And then I can see that this is kind of nice because 2 of the x will cancel 2 of the x here. So this is going to be left with 10 divided by x. And guess what? When I plug in infinity, I'm going to have 10 divided by infinity, and a small number divided by a big number is going to give us a big 0. I mean, it's going to give us 0. Yeah. So if you remember, if we are thinking about horizontal asymptote, we said whenever the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is 0, which is showing it right here. Good. So that is the idea with this. Anytime you see x is approaching infinity, think about the horizontal asymptote. Now, let's look at C. As I said, always when you see a limit, the first thing that you need to think about is direct substitution. But anytime it's a fraction or a rational function, think about the denominator. What is going to happen when you just plug it in? So plug in 3 here, and you see that 3 minus 3 is going to give us 0. We don't like that thing. We don't want to see any 0 at the denominator. So what we are going to do is, let's try and simplify and see if we can get something out of that. So this can be written as limit x is approaching 3, and then we cannot simplify the denominator, so still x minus 3. But let's look at the top if we can simplify that. So x squared minus x minus 6. Now let's look at factors of 6. What times 6 is going to give us 6? 1 times 6 is going to give us 6. But I asked myself, can I add or subtract this and get 1 or negative 1? No. So I need to think about 2. Can I multiply 2 to any number to get 6? Yes, of course. I can think of 2 and 3. So now 2 times 3 is 6. Can I add or subtract this to get negative 1? Yes, of course. So for me to get negative 1, then I need to have minus 2, oops, um, 2 minus 3, right? And since this is negative x, then I can write this one as 2x minus 3x, which is going to give us negative x. Is that right? So it means that I can write this one as x squared plus 2x minus 3x minus 6. So what did I do? I was trying to write this negative x like to be two terms so that I can share them, this and this. So factor x out, here we'll be left with 2x, and then factor 3 out, 2x. I said 2x, x plus 2. And then when I factor this and this out, this is going to give us x plus 2, x minus 3. Is that right? So it means that the numerator top here can be written as this. So let's write it down. X plus 2, x minus 3. And then the magic happens. This cancels this out. Good. So since the magic has happened, then what you can do is now what will be left? Limit x is approaching 3, and to be left with x plus 2, hope. And then now it is a polynomial function, so we do direct substitution, 3 plus 2, and we get a big 5. Wow. So that's what we are going to get from this. Let's look at D. D, this is kind of the same function. Can you see that? Yes. But the only thing that's changing here is x is approaching 0. So let's think of doing direct substitution, and this is a fraction, so I'm concerned about the denominator. So let me plug in 0 here, and I get negative 3. So it means that there is no problem when I plug in 0. So I'll just do 0 minus 6 divided by 0 minus 3. So the top will be minus 6 divided by minus 3, and I'm going to get a big 2. So you see the way the 10 is. Good. Now we have E here. Again, x is approaching infinity. So we are thinking of horizontal asymptote. So if this is a horizontal asymptote, we're thinking of the degree of the numerator is the same as the degree of the denominator. So it means that this should be equal to the coefficient of this divided by the coefficient of this. And it is true. But let's go through the right procedure. So this is limit x is approaching infinity. So I'll pick x squared divided by 4x squared, because on the top, the polynomial function, the one with the highest degree is this, and the same thing to this one too. And we can see that the magic happens. This cancels that, and it will be left with limit x is approaching infinity, 3 over 4. And we know that limit of a constant is the constant. So we are going to have a big 3 over 4. So that's what you are going to get at the end of the day. Oh, let's look at the F. Now F, we want to look at limit as x is approaching 4. But we have two functions. Remember, anytime we talk about limit as x is approaching something, like limit x is approaching 4, for us to conclude on this, we need to look at limit as x is approaching 4 from the left and limit as x is approaching 4 from the right. So for us to conclude on this limit here, we need to conclude on this and that. So now let's check that. Let's look at limit as x is approaching 4 from the negative. Which function are we going to use? When you say x is approaching 4 from the negative, it means that all the values of x are less than 4. So with this one, which one is less than 4? This, because we are talking about the negative. So the function that we are going to use is x squared minus 9, and this is going to give us Now we plug in the 4 because this is a polynomial function. Don't be confused with this guy here. This guy here is just showing us that we are coming from the left and helps us to choose the function. So we just plug in 4 here, and we are going to have 4 squared minus 9, and I have 16 minus 9, and I'm going to have 7. Let's look at the right. Limit x is approaching 4 from the right. So it means that if it is positive, it means that all x values should be greater than 4, which is here and that. So we are going to have x plus 3, which is equal to, plug in 4 because this one is just showing us the direction. So we are going to have 4 plus 3. The magic is happening. This is 7. Indeed, we said that for this limit to converge, or for this limit to exist, the left and the right should be the same. And indeed, left is the same as right. So this limit here is equal to 7. So now since limit s is approaching 4 from the left of x squared minus 9 is the same as limit x is approaching 4 from the right, x plus 3, and they are all equal to 7, then it is not hard to conclude that limit x is approaching 4 of x squared minus 9, x plus 3, less than or equal to 4, greater than 4, is equal to a big 7. So that is what we just need to conclude on. Good. Now let's look at the next question. Next question is just derivative. The questions are very nice. We have question 6, we have question 7, we have question 8, we have question 9. So stay here with me. Let's just go through together, right? Good. Now this one is like we need to use the power rule, right? So what will be f prime? Kind of very simple here. So let's use the power rule. Differentiation, don't forget, we are not doing entire derivative. We are doing derivative. So this is going to give us 6x squared. Right now we know how to do derivatives, right? So 3 multiplies this, subtract 1, plus the 2 drops to multiply this, giving us 10, subtract 1, and it will be left with just x. And then plus, when I differentiate x, I get 1, so I'll have 7. And when I differentiate the constant, I'm going to get 0. So this will be f prime. Nice. That's A. This is very straightforward. So now let's look at B. Don't forget, the question is saying that we should use the power rule. So we cannot use anything. Here, we cannot use product rule because the question is saying that we should use the power rule. So only thing that we can do is we can try to expand this, right? So expand, 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 expand. So x times x is x squared, x times 7 is 7x, minus 4 times x is minus 4x, and then minus 4 times 7 should be minus 28. Is that right? Yes, it's right. Good. Let's group them. So x squared plus 3x minus 28. So still, this is h of x. We have not taken the derivative because we were trying to simplify it. Now let's find h prime of x, and this is going to give us 2x plus 3. Ooh, this is very nice. So this is what we are going to get at the end of the day, which is okay. Let's look at C. So you see, some of the functions, when we see it, we just do straight finding the derivative, right? Because this is a polynomial function. We don't need to do anything. We just differentiate. Look at this. This one, because the question is saying that power rule, we need to simplify this to here before we take the derivative. So some of the functions, you need to simplify them first. This one like this, we need to simplify it before we can take the derivative. So how can I do this? Gen of x is equal to, this is the same as 10x to the power negative 1 plus 6x to the power 1 over 2. So now that I'm done with the simplification, then I can differentiate that. So this is gen prime of x will be equal to negative 1 drops to multiply. So negative 1 will multiply 10, giving us minus 10. Then subtract 1, so it's going to give us minus 2 plus half will drop and multiply 6. So 6 times half, let me just write it down. And then I subtract 1. So 1 over 2 minus 1. So this is going to give us minus 10. I can decide to simplify this if I want. I can decide to bring it back down so that I have x squared plus this is going to give us 3. So I'm going to have 3. Then half minus 1 is minus half. I can decide to stop here. Yes. But if we want to do further simplification, then you can say that minus this x squared plus 3 divided by half. And still, if you want to do simplification, you can say that this is the same as x squared plus 3 square root of x. What you can do is you can stop here. If you cannot do all this, you can just stop here. You can even decide not to do this like this. So you can just stop at this side where you have minus 10x minus 2 plus 3x to the power minus 1 over 2. Yes, you can stop here. So from here, you can move to this place and you are done. All right. So this is question 5. Let's look at question 6. I hope you are enjoying the video. Stay here. We have 3 more questions. Is it 3? Yes. So when I'm done with this, we have 3 more. So first, find f of 1. So f of 1 is just putting it inside this. So very simple. 5, 1 squared minus 3 times 1 plus 4. So this is 5 times 1 minus 3 plus 4. This is 5 plus 1, and this is going to give us a big 6. Now we need to find f prime of 1. But for us to get f prime of 1, we need to first find f prime of x. So let's do that. What is f prime of x? Kind of very simple. So differentiate this, and we have 10x minus 3. So now what is f prime of 1? And we're having 10 times 1 minus 3. This is 10 minus 3, which is equal to a big 7. Now, find the equation of the tangent line to the function at this point. So, equation of the tangent line, we have so many formulas that we can use, right? But here, what I'm going to use is I'm going to use the one which is in terms of f, like what is in terms of x. So first, I will name this one as x1, which is equal to 1. So that now my function will be y minus f of x1, which is equal to f prime of x1 x minus x1. x1 is equal to 1. So I'm going to have y minus f of 1, which is equal to f prime of f of 1 x minus 1. So you see that when I use this formula, it's good for me I definitely see that I need f prime of 1, which we have already found it. I need f of 1, which we have already found it. So 6 and 7. So I'm going to have a big y minus a big 6, which is equal to a big 7 x minus a big 1. And if I want to simplify, I can stop here. But if I want to simplify, I'll have a big y minus 6, 7x minus a big 7. Yeah. And then I can write this one as a big 7x minus plus 6. And this one will be a big y 7x minus 1 if I want to simplify. But you can also stop here and you'll be fine. Good. So unless you can stop here, unless maybe the question is saying that leave it in the y-intercept form. This is the y-intercept form. So minus 1 is the y-intercept, and this is the slope. Good. Let's look at question 7. I love question 7. Question 7 is very simple. Just look at the graph and just put the answers there. So what is limit as x is approaching 4 from the positive of gen of x? So the question is f. The question is 4. So I need to go and locate my 4. X is approaching 4. So this is okay. So this is my 4. So what I'm going to do is I'm going to put a line that passes through 4. So always that's why I do it. Then when I put the line, the one on the right is positive and the one on the left is negative. So since I'm thinking about the positive, it means that I'm thinking about this side. So I need to look at the graph on the right side of this line here. So I can see this graph. And then the graph that is on the right, I move it towards this line. So let's move. You got here, then you trace it to the y, and it's very simple for you to see that, okay, this is 6 right here. So this is not difficult to see that this is equal to 6, or let me say a big 6. Then we need to look at the negative side of -4. So this is the negative side. So look at the graph which is close to this line from the negative side. Then you move along the graph towards this line here. So this is the graph. So I'm moving along this line towards this line. So I move and I got here. I trace it to the y-axis. This one too is not difficult to see that this is going to give us a big 3. Now, as we said, for us to conclude the one without negative or positive, then the left and the right should be the same. So since they are not the same, this does not exist, because you can see that on the graph, even this is a jump discontinuity. Good. So it means that it's not going to be the same. Now let's look at gen of -2. But for us to conclude on this, we need to look for limit x is approaching -2 from the minus, and then also look for limit x is approaching -2 from the positive. So let's go and locate -2. So -2 is fortunate for us. We have -2 here. Good. So remember, when I draw this line, this is my positive, this is my negative. So what will be the negative side? Let's look for the negative side. Then when we finish, we come and look at the positive side. So on the negative side, we need to look at the graph that is close to this line on the negative side, and we can see this graph here. Move it towards that line, and we see that this is where the graph is ending, and we go and we have 3. So this is 3. Let's go to the positive side. Positive side, pick the graph that is close to this line here, and this is the graph. So let's move towards that line, and also here, this is also 3. So this is also going to give us 3. So this is the same as that. So we can conclude that this guy here is equal to 3. Nice. Now, whenever you don't have limit and we have just plug in, what you just need to locate is you need to locate something on the graph that is, let's say, shaded, right? So these are the one that is shaded. So let's go and look for 2, -2. -2 is here. We can see that there is one shaded here. This is open. So we don't like the open. We want the one which is shaded. We trace it and we have -3. So this is equal to -3. The same thing for gen of 4. We need to look at this and we look at the one which is shaded, which is just right here. So which is also 3. So this is going to give us 3. So you see that, just look at the graph and put them in there. If you are very good with this one, you should be able to get, if here is 10/10, you should be able to get the 10 points, everything here. All right, let's look at question 8. Then from question 8, we look at question 9, and then we are done with this video. Indicate whether each statement is true or false by circling the appropriate answer. If the function if the function is continuous at x is equal to c, then limits as x is approaching c of f of x exist. Is that true? Yes, of course. This is true because we said for the function to be continuous, we had three properties. We had one, we said one, f of c. So this the point here is c. So f of c must exist. And two, we said limit as x is approaching c of f of x must also exist. And you can see that this is what is right here. And then the third one was limit as s is approaching c of f of x should be the same as f of c. So these are three properties or three things that we need to look at whenever we are talking about continuity. So this is true. Yes, this is a big true. Let's look at this. If this is continuous at x is equal to c, then the derivative of this, that is f prime of c, exists. Is that true? Okay, I can pick the red and say this is a very big force, but I will show you how. So for example, let's assume that we have f of x, which is equal to absolute of x. Now this is continuous at x is equal to 0. Yes. So here I'm assuming that c is 0, and I'm assuming that my function is also this. This function is continuous because the graph for this, it's kind of this. So you see that it is continuous here like that. But can I differentiate this? The differentiation of this function does not exist. How did I see that? Now we know that this f of x can be written as, now the absolute value is telling us that we have negative of x and we have positive of x, where x is less than 0 and s is greater than or equal to 0. So f prime for this is going to be -1 and 1. X is less than 0, s is greater than 0. So we see that the function is not continuous because the left is not the same as the right. So I said not continuous. The function, the derivative of the function does not exist because this is not the same as this. So now we conclude that yes, this is indeed a false question. The break-even point is the value x or x value where the cost is equal to profit. This. Is that true? Let's find out. We know that profit is equal to revenue minus cost. Now we are talking about break even. When you say break even, it means that we don't have any profit. So that is when break even is when profit is equal to 0. So it means that when profit is equal to 0, we are going to have 0 is equal to r of x minus c of x. And r of x should be equal to c of x. So this is the true statement. When we have a break even, revenue should be the same as cost, not cost being the same as profit. So this is a big force. Interesting. Let's look at D. Now, if f of x is equal to gen of x minus this, then this is the same as, is that true? Yes, this is, of course, this is true, right? So this is the property of differentiation, right? So if I have f of x, which is equal to 2x minus x squared, then this is the same as the f prime will be differentiating this, which will be 2 minus differentiating this, which is 2x. So the idea is differentiate gen. So let's assume that gen of x is this, and differentiate h. Let's assume that h of x is also this. So this is indeed true. Let's look at the last one. If this is equal to this, then this is that. Is that true? I think this is a big false because we know that this is supposed to be the product rule. So f prime of x should be equal to differentiate gen and maintain h of x plus now differentiate h and maintain gen of x. So this should be the product rule. Sure. So yeah, so how many fours? 3 fours, 2 of them is true. Okay, so let's do the last question and we are done with this video. Now question 9, we want to sketch. We want to sketch. So given this f of x is defined for all real numbers. Okay, fine. We've heard you. Then as x is approaching 2 is equal to 3. So anytime you see something like this exist, it means that the left and the right are the same. So this implies that limit as x is approaching 2 from the left of f of x is the same as limit x is approaching 2 from the positive of f of x, and they are all equal to 3. That's the reason why we are saying that this is equal to 3. So now let's come to the graph. Let's locate 2. So x is approaching 2, right? So when we locate 2, and then this is approaching 3. So we are going to have something like this here. And when we are approaching from the right, we are getting 3, right? And then when we are approaching from this one too, we are approaching 3 somewhere here. So I was able to just indicate this graph somewhere there. Then f of 2 is -1. So f of 2 is -1 means that I'm going to have the graph to be somewhere here. F of 2 is -1. So f of 2 is -1. So since f of 2 is -1, then this one is like point discontinuity. So it means that in the middle here, I'm going to have open because this is shaded. Good. So I'm going to have open. Good. So this one should be open. So I was able to also indicate this one. Then the question is saying that when x is approaching infinity, it gets to 0. So it means that when this is the last x value. So when I'm approaching x is going to infinity, I need to get close to 0. So it means that I'm getting close to 0 when I'm going to infinity. Let me just maintain it like that. Or let me just get close to 0. We'll combine the graph. So I'm done with this one too. Then when x is approaching negative infinity, so negative infinity is this side, it's also approaching 2. So this is a horizontal asymptote. This is also a horizontal asymptote. So you see that the horizontal asymptote for 0 is kind of going to be on this line. That's the x-axis. And then we have another horizontal asymptote, which is 2. But this one, x is approaching negative infinity. So which is 2, we are going to have something like this. So that when we are approaching this side, we need to get close to. So we don't know whether we are going to approach it this or we are going to approach it this. So any of them is approaching 2, whether down or top. But now that we know this, also now the information is already in the graph. So like let's try and combine them. So we can see that there is one graph going this way, there's another graph also trying to go. So we need to combine this. One thing that you need to remember is we can cut or we can go through the horizontal asymptote. So we don't have problem whenever we are going through the horizontal asymptote. So since this one is going down and this one is going down, this is going to be like this. Let me use different color to do that. So this is going to be like that. Good. Getting close to 0. So when we are approaching 0. And then we have this graph, but we don't know where this graph is going to be. But since we have this graph here, then we can combine this graph to this graph instead of this. So it means that we are going to take away this out and then we combine this graph and this graph. So we are going to have something like this. So let me take this one out. Remember, this one is supposed to be a hole. So I'm going to have a graph that is going to close to 2. So this graph defines the function that we have. So he's saying that this is defined for all x values. This one, we have just a point discontinuity at s is equal to 2. That's all we have. So it's kind of point discontinuity is removable. So that's the reason why it's saying that it's defined for all x values, right? So that's what you're going to get. So we can see that now when I'm approaching this to the negative infinity, I'm getting 2. When I'm going to positive infinity, I'm getting 0. And when I'm going this way from the positive, I'm getting close to 3. And when I'm going this one too, I'm getting close to 3, which will define the limit as x is approaching 3. So this will be the graph. Okay, let me change this one to blue. Good. So this is what I'm going to get at the end of the day. All right, so this is the end of the video. Don't forget, this is the roadmaps to final exam. So after this is exam 1 that we took this spring 2025. So the next video that is coming up is the exam 2 spring 2025. Then after exam 2, we move to exam 3 spring 2025. Then the last one will be the final exam, which is spring 2024. That one will be last year, right? All right, see you in the next video.